Hi everybody, today we are going to continue talking about quadratic functions and introducing quadratic functions. We are going to work on graphing quadratic functions now, so taking that equation in standard form, figuring out how to put it in vertex form, put it in factored form, how to graph it, how to find the vertex, all of that good stuff. So there's a lot of things on these notes, and so don't panic, we're going to go through them all together. So we are going to start by looking at our equation in standard form. So this is f of x equals x squared. So notice that if this is our quadratic function equation, here a is equal to 1, because we have invisible 1 here, and then b and c would both be equal to 0, which is why we don't see anything coming after. This equation that you see here, f of x equals x squared, is called the parent function. It's the simplest version of a quadratic function we can come up with. So we're going to start here, and then we're going to look at two more complex versions of a quadratic function. So as we said already, a equals 1 in this quadratic, b would equal 0, and c equals 0. So we're going to use this information to help us break down each piece of these notes. So we're going to start with the axis of symmetry. So the equation for axis of symmetry, that line that divides a parabola in half, is x equals negative b over 2a. So we're going to use that equation, and in this case, b is 0, so we have negative 0 over 2 times 1, because a is 1. Well, 0 divided by anything is 0. So we know that this graph is symmetric around the line x equals 0. So that is our axis of symmetry. The next thing we're going to do is use this axis of symmetry to find the vertex. So we're going to take this number up here. And to find the vertex, we are going to substitute in the axis of symmetry to find the y coordinate of that axis of symmetry. So where does this axis of symmetry, where on the graph does x equal 0, so that we can find the y coordinate at that point, because that's going to be our vertex. So to do that, we're going to sub in 0 for x. We got that 0 from the axis of symmetry. And our y coordinate is also 0. So that means that h and k, the coordinates of my vertex, are 0, 0. So that leads us to being able to write our equation in factored form, or in vertex form. Now that I know my vertex and I know my a value is 1, I'm going to have f of x equals 1. I don't need to write that 1 because it's invisible. X minus 0 squared plus 0. This is a lot of extraneous writing. We don't actually have to write all of this. This is the exact same thing as x squared if you simplify, but I want you to see what vertex form looks like written out. Factored form, for factored form, we'd actually factor x squared. X squared is really nice and easy to factor because it's just two things. It is x times x. So if I wanted to write this in factored form, I would write f of x equals x minus 0 times x minus 0. I know it's x minus 0 because that is what will leave me to x. So these are our three different forms of this quadratic function. F of x equals x squared is standard form. F of x equals x minus 0 squared plus 0 is vertex form. And f of x equals x minus 0 times x minus 0 is factored form. Now that we have this information, we're going to use it to go ahead and graph our function. There's a couple different ways that we can graph this function. I'm going to choose to make a table first. So I'm going to start with my vertex in the center of this table, 0, 0. Then I'm going to use what's called the 1a, 3a, and 5a rule. So as my graph goes up, I'm going to add 1 times a, 3 times a, and 5 times a. So if a is 1, 1 times a would be 1. If a is 3, if a is 1, 3 times a is 3. I'm going to do that on the other side of the vertex as well. So I'm going to add 1a, and then I'm going to add 3a. Again, I got my a value up here because I knew that there was an invisible 1 in front of x squared, and that's the a value. Now I'm going to graph my quadratic. So I went ahead, I'm going to draw some axes. Excuse how not straight my lines are. I'm going to put a point at negative 2, 3, a point at negative 1, 1, 0, 0, 1, 3, and 1, 1, and 2, 3. I'm going to connect my dots. This is my parabola. This is the graph of x squared. Next up, I'm going to write my domain and my range. So my domain is all real numbers. I'm just going to write AR numbers to remember because we go from a left arrow to a right arrow. Here's a secret. All quadratic functions have a domain of all real numbers. It makes domain for quadratics very easy. They always go left to right from an arrow to an arrow. My range is going to go from 0 to infinity because the lowest point is at 0 and the highest point is at infinity. The last thing I need to record here is my roots. So for roots and zeros, a root or a 0 is the exact same thing as an x-intercept. Roots and zeros are just x-intercepts. So here, my x-intercept is at 0, 0. That is going to be my root. That's an important number for us right now. It's the vertex and the root. So there's a lot going on with that 0, 0. Let's go ahead and move away from this parent function to one that has a few more numbers in it. So this time we're going to look at x squared plus 6x plus 8. I'm going to move my face so I can write a little easier. In this example, a is still 1, but this time b is 6 and c is 8. I got those numbers by looking at the coefficients and the constant here and comparing them to the standard form of my quadratic function. Then I'm going to find my axis of symmetry. X equals negative b over 2a. So in this case, that's x equals negative 6 over 2 times 1. Negative 6 divided by 2 is negative 3. So that tells me that the line at x equals negative 3 is going to be my axis of symmetry. My graph will be symmetrical around that line. That's also going to be the x-coordinate of our vertex because our vertex always intersects the axis of symmetry. So I'm going to take that x value and I'm going to come up here and I'm going to use it to find the vertex. So I'm going to plug in negative 3 into my equation. That gives me 9 minus 18 plus 8. 9 minus 18 is negative 9 plus 8 is negative 1. So my vertex, my HK, is negative 3, negative 1. Now that I know this vertex, I can use this to figure out my vertex form. So vertex form here, A is still 1, we know that. So if A is 1, we're going to not worry about that for right now. And we are going to have 1 times x minus h. Well, x minus negative 3 is the same as x plus 3. So I'm going to write in x plus 3 squared minus 1. So that's my h value. We have to switch the sign because it's a minus. And then k is not a minus, so we do not switch the sign. We only switch the sign for the h value. So vertex form of this quadratic is x plus 3 squared minus 1. Then we're moving into factored form. Factored form means we're going to factor this. Again, I know my h value, or my a value, I'm sorry, is 1. So I'm not going to write that. To factor x squared plus 6x plus 8, we need to think what multiplies to 8 that adds together to get to 6. Well, 2 and 4 multiply to 8 and add together to equal 6. So I'm going to write x plus 2, x plus 4. That's my factored form. Moving on from there, we're going to go ahead and graph this function. So again, we are going to start with our vertex. So our vertex is at -3, -1. I'm going to fill in my x values around that. And then I'm going to use my plus 1a, plus 3a, plus 5a rule. So a is 1. So on both sides, I'm going to add 1. Then on both sides again, now I'm doing plus 3a. So 3 times 1 is 3. So now I'm going to add 3. Once I have some points, I'm going to go ahead and graph this. Again, excuse my wiggly axes. So I know I have a point at -5, +3. I have a point at -4, 0, a point at -3, -1, a point at -2, 0, and -1, 3. When I connect those dots, that is the graph of my quadratic function. From there, I'm going to write the domain and the range. Remember, in our last example, we learned the domain is all real numbers. Here, the range goes from -1 to infinity. The roots are the x-intercepts. So there's an x-intercept here at -4, 0. And there's an x-intercept at -2, 0. We're going to look at one more example together. The reason I wanted to look at this example is because it has a different a value. This time the a value is 2. The b value is -4, and the c value is 6. So we're starting with the axis of symmetry. The axis of symmetry, -b over 2a, in this case will be, -4 over 2 times 4, or 2 times 2, I'm sorry, because of our a value. It's also a -4, which makes this a +4, because our v value is -4. 4 divided by 4 is 1, so my x value is going to be 1. I'm going to take that x value and come up here to help me find the vertex. So I'm going to plug in my x value from the axis of symmetry. Two minus 4 is -2, plus 6 is 4. So my vertex should be 1, 4. Next, I'm going to look for my vertex form. This time, in vertex form, my vertex is going to be 2 times x minus 1 squared plus 4. The 2 is my a value. The 1 comes from my vertex, and the 4 comes from my vertex. In factored form, we're going to start with our a value as well. F of x equals 2. But this time, in order to factor, we need to divide each term by 2. So when I divide each term by 2, I'm left with x squared minus 2x plus 3. The pair of numbers that multiply to 3 and add to 2 does not actually exist. So the only numbers that multiply to +3 are +1 and +3, and -1 and -3. None of those pairs add to -2. So we do not have an equation in factored form. It's impossible to factor this specific function. That, however, does not mean we can't graph it. So to graph this, we're going to start at our vertex 1, 4. We're going to fill in our x values around that. Then we're going to use that 1a plus 3a plus 5a rule. So this time a is 2, so it's going to look a little bit different. When I add 1a to both sides of 4, I'm going to be adding 1 times 2, or 2. So that's going to be 6 and 6. Then when I add 3a, I'm going to be adding 3 times 2, so that's 12 and 12. Now I'm going to go ahead and graph this. There aren't enough boxes on my chart right now to graph all the way up to 12, so I'm going to actually, I think I'm going to choose to count by 2s on my y-axis. They'll still count by 1s on my x-axis, so my graph might look a little bit squashed. That's okay. So we have a point at -1, 12. Again, I'm counting by 2s on my y-axis. Then I have a point at 0, 6, a point at 1, 4, 2, 6, and 3, 12. So that's my graph. The domain is all real numbers. And the range, this time we're starting at +4 and we're going to infinity. The roots and zeros are the x-intercepts. There are no x-intercepts here, so we are going to write none. You'll notice that there's a pretty strong correlation between numbers that we can't factor and times when there's no roots or zeros. Thanks for watching. I hope this video was helpful. I know we went through a lot of information here. We went through all the different forms, the axis of symmetry formula, how to find a vertex, how to graph a quadratic function, a lot of information. But hopefully these 3 examples were helpful. Make sure you subscribe if you're in my class so you never miss a video, and I'll see you next time.